Welcome to Math with Father. Welcome to Math with Father. Subscribe, like and share.
The second equation, quadratic equation. So exponential equations, which leads us to quadratic equations. How do we solve these kinds? So our next section, we will be moving on to quadratic equations. So similar to how we started with the linear equation. So now we have b raised to the power 2x equals b to the power y. And so from the power law, it states that anytime we encounter this exponential or this index from a raised to the power x all raised to the all multiplying y, this is also written as a raised to the power x times y, x multiplying y, and this gives us a xy. So looking at this condition, the b raised to the power 2x is also, it also has a power multiplying another power, so it is 2 multiplying x, similar to this one. So we're also resolving it this way. So this could also be rewritten as b raised to the power x all multiplied by 2 equals b to the power y. So with the condition, it states that if the base are the same, so we have b as a base, we have another b as a base, so this could be rewritten as x squared equals y. And any equation that has its highest index as 2 or the highest power as 2 is called a quadratic equation. So quadratic equations are of the form a x squared plus bx plus c is equal to 0. So this is the general quadratic equation. So meaning at the end, after coming out with a common base and then equating the powers should look similar to this kind of equation. So to obtain the solution of the exponential equation, 2 raised to the power 2x minus 5 multiplying 2 to the power x plus 4 equals to 0. So this is an exponential equation. And how do we solve this? So solution. From the first term, we have 2 raised to the power 2x. So this obeys the power law. Minus 5 raised to the 5 multiplying 2 raised to the power x plus 4 equals 0. So what we are going to do is we are going to change or make each term have a similar base. We are going to resolve this to get a similar base for all the terms. Anytime we encounter this a raised to the power x all multiplied by y, this is also written as a raised to the power x by y, and the simplified form of this is axy. So our first term, which is 2 to the power xy, also looks similar to this. So we have 2 as our a, we have or y, and then we have to the power 2 or x as our x. So we are going to resolve it to suit this, something of this sort. Now the clue is every question comes with a clue, and the clue is there will be a specific base given which should suit each term. So each term should bear that base. And then per this question, the unique base is 2 to the power x. So now we are going to resolve this to also suit this one, and then resolve this to also have or bear the same base. Now 2 to the power x. So since this is the unique base, this with or in the power, using the power law, is written as 2 to the power x multiplied or raised to the power 2. So I've resolved this into to this. So I have 2x raised to the power 2 minus 5 multiplying 2 raised to the power x plus 4 equals 0. Okay, so comparing this to the general equation, which is comparing this to the general equation, which is a x squared plus bx plus c equals 0. Now we have 2 to the power x raised to the power 2. So looking at this, we have to the power 2, we have x which is to the power 1, we have to the power 1, and then we have a constant term which is our c. So what we are going to do here is we are going to set the unique index form, which is 2x. So 2x, we have 2x, and then we have a 2x here, but students at times confuse themselves with it. And the truth of the matter is, looking at this, the first index of 2 to the power x is 2. The second index of 2 to the power x is 1. So what will be the last index of 2 to the power x? That will be 0. So this can be written this way: 2 to the power x raised to the power 2 minus 5 raised to the multiplying 2 to the power x by 1 plus 4 multiplying 2 to the power x 0. 0 is equal to 0. So we can all see that the power decreases as we move to our right hand side. So here the first power is 2, the second power is 1, the third power is 0. And from the 0 index, it says any number raised to the power 0 is 1. So 2x to the power 0 is 1, and 1 times 4 gives us 4. So that is why this is not written, but this is the notion behind the constant term. So we have 2 to the power x as an index, 2 to the power x as an index, 2 to the power x as an index. So looking at the terms, it sails or cuts across. So now what we are going to do next is we are going to set the common index form, which is 2 to the power x, to an unknown. And here, since x was used in the question, we will set it to a different unknown. So now let's y be equal to 2 to the power x. We substitute y inside our equation. So anywhere we see 2 to the power x, we replace it with y. So the first one, we have y, which is this 2x raised to the power 2 minus 5 multiplying y plus 4 equals 0. So this leads us to our proper. So we are going to resolve the value for y. We are going to resolve the value for y. So what we are going to do is we are going to break this into two factors, and with this we have several or numerous ways of solving this. So we can go use the quadratic form to find for the value y. We can also use the factor form. So let's use the factor form. So with the factor form, what we are going to do is we are going to multiply the coefficients, or we are going to find the product, and then we're also going to find the sum. So the product of roots and then the sum of roots. So with the product, we are going to multiply the coefficient of y squared, which is 1, by the coefficient of, or for the constant, we are going to multiply the coefficient of y squared, which is 1, by the constant term, which is 4, and the result is 4. So from this product, which is given us 4, we are going to find two factors from this product. When summed up, would be given us 5, and then from the factors of 4, so here we would be using negative or positive. We have negative 4, negative 1. Negative 4 times negative 1. Negative 4 times negative 1 gives us 4. Negative 4 plus negative 1 also gives us negative 5. So when multiplied, we should get in 4, but when summed up, we should get in negative 5. Now we have y squared minus, so with the sum, which is negative 5y, we are going to replace it with the summation of these two factors. The summation of these two factors, 4, and since y, so y, negative y is our 1, negative 1y, and 1 multiplied by anything gives us the same thing, so which is negative y minus 4y plus 4 equals 0. Now we have y squared as our y, we have negative 5y as negative y, negative 4y. So summing up these two gives us back negative 5y plus 4, we have plus 4 equals 0. So we are going to group this into factors. Now I have y squared minus y into brackets, or plus negative 4y plus 4 is equal to 0. So at this point, what most of the students do is, in the grouping, they make this petty mistake, and then it costs them really much. So in grouping these terms, in grouping these expression or these terms, what I have noticed in class is, anytime we have y squared, or anytime we have this quadratic equation, what most of the students do is, they make, in the grouping, they do make mistakes when grouping. So they do it this way: y squared minus y minus 4y plus 4 is equal to 0. So anytime you factor the operation sign when grouping the other two terms, we do it this way. This is the wrong thing, because when you try to now simplify it this way, you are not still going to get back this. We have y squared minus y minus by 4y negative 4y. We have minus by positive 4 giving us negative 4 is equal to 0. And this is not the same thing as this. We have y squared minus y minus 4y minus 4y. See here with the constant term, the original equation was positive 4 or plus 4, and after simplifying this we are getting negative 4. So this is not the ideal way of simplifying this expression or equation. So please, we should all bear in mind and then stick to the right thing. So it's either you group them into two inside a bracket, so y squared minus y in a bracket, then also do same for negative 4y plus 4 in also another bracket, and between these two brackets the operational sign between them should be plus, or you can also choose to write it this way: y squared minus y minus out, which is this minus sign, bracket open, 4y minus 4 is equal to 0. So if it's done this way, when simplifying it back to this form, you will still get back this equation or expression. So if the negative sign is taken outside, it's going to affect the operational sign that we have inside our bracket. So let's simplify and attest to the fact. Y squared minus y minus 4y minus minus, which is plus 4 is equal to 0. So doing it this way, we have y squared. Let's compare. Now compare this to this. So we have y squared minus y minus 4y minus 4y plus 4 equals to 0. So when grouping, make sure when or which operational sign to change. So if you want to group it as how you were given from the equation this way, then group them into two, and between the two brackets include plus. If you also want to factor out the negative sign, then if the negative sign is factored out, it should also affect the sign inside the bracket. Let's move on. Okay, so we are going to factor the commons now. We have y squared minus y, and the common expression here is y. So y is taken out, multiplying y minus 1 plus, so the common thing here to single out is negative 4. So here I'm taking or factoring negative 4 out in order to suit this factor. Y minus 1 equals 0. Y minus 1 minus 4 out, y minus 1 equals 0. So let's go back and check our equation. We have y out, y minus 1 minus 4, y minus 1 equals 0. Okay, so at this juncture we have y minus 1 repeating itself here, y minus 1, and we have y minus 4, which is this together with this, y minus 4 as one factor, And since y minus 1 repeats itself, 1 is chosen. Minus 1 equals to 0. So we have our factors and we are moving on to find, or in finding our zeros. Now we equate each factor to 0 and then resolve. Now our value y is equal to 4. Similar to this, y minus 1 is equal to 0 and y gives us 1. We are not done. We've resolved or calculated for the value of y, but you should bear in mind that from the question, y wasn't part of the question. We introduced y. So this was the original question. This was the original question. And then we changed this question to suit a similar index form, which was 2x. And that 2x was set to the variable y. So we said y should be equal to 2x. Now that we've gotten the value y, we are going to equate it to 2x. So we said let y be equal to 2 to the power x. Now we have y to be 4. So anywhere we see y, we are going to now replace with 2x. Now we have 2x, which is this y. Now this y is equal to 4. So at this point, we change the expression to have a similar base, and the smaller base here is 2. So we will change 4 to also have a base of 2, and 2 repeating itself 2 times gives us 4. So we have 2 as 1, so we are picking 1, and then how many 2's? We have twice of it. And if the bases are the same, the exponents are equated. So we have x to be 2. Let's move on in resolving for this y. So when y is equal to 1, what is it saying? When y is equal to 1, y is equal to 1, so we would let, so from our onset, we said we should let y be equal to 2 to the power x. Now we have 2 to the power x equals 1. And from the properties, which says that any number raised to the power 0 is 1. So meaning, now finding or in search of a similar base or a base of 2, we know 2 to the power 0 is also 1. Now we replace this 1 to this index form. We have 2 to the power x equals 2 to the power 0. And if the bases are the same, the exponents are equated. We have x to the power 0. So from our question, we have two values of x as 2, and then x as 2, and x as 0. So we conclude, hence x is equal to 0 or x is equal to 2. So these are the solution sets of our equation. These are our solution sets of our equation. These are our solution sets. Of our equation, 2 to the power 2x minus 5 multiplying 2 to the power x plus 4 equals to 0. So when this kind of equation is given, then after going through all this procedure, you would now ascertain or get to know that this question leads us to a quadratic equation and is now dealt with. So I'll be giving out numerous examples or questions to try your hands on. So if this video was very helpful, please subscribe to my channel, give it a thumbs up, and post me on post notification anytime I drop new videos. Thank you for your time. I'm out.